Today we'd like to talk to you about the Series 5600 control, which is available in either a 12-day or 7-day program timer clock or with a meter-initiated regeneration system. The 5600 control was designed back in the latter part of 1979 and introduced to the market in early 1980. The meter option, which we have available on it, came into the marketplace about 1982. Today there are in excess of 200,000 meter systems on the market. The design of the control lends itself well to the range of tank sizes from 6-inch diameter all the way through a 13-inch diameter, and we use the control for not only softener applications but also carbon filters and iron filter systems. A couple of the unique features in the 5600 series control that I'd like to talk to you specifically about at this time is the piston seal spacer concept around which the control is designed, which incidentally is really the heart of every Fleck valve on the market. The reason it's so unique is as the piston is indexed by the drive motor, it moves down and then back up through the stack of compressed seals and spacers, completing its regeneration cycle. As it does this, the piston lobes are wiped on the inside diameter of each of the seals, and we can, in effect, call the control self-cleaning. The second feature related to the piston design is the hole in the center, which equalizes the pressure above and below the piston at all times. Since the piston is the only in-stream moving component, we keep the pressure inside of the valve balanced so that the motor which drives the piston is not working any harder if it's on 120 pounds inlet pressure versus 30 pounds inlet pressure. The other feature that's available in the 5600 series control is the meter option. You notice that the impeller in the meter moves quite freely and is quite sensitive at low flow rates. It can register in flow rates as low as 0.15 gallons per minute, or as small a quantity of water as a pint per minute, and it's accurate at low flows of 0.25 gallons per minute, which is approximately a quart. The meter monitors the flow of water coming from the outlet port of the control and registers quantitatively how much water has been used since the previous regeneration, therefore scheduling subsequent regenerations only after the entire capacity of the softener is expired. The design of the meter is simple, lending itself to very simple programming, and also from the serviceman's standpoint quite simple to understand and to apply and troubleshoot in the field. Mike, could you tell us about the L backplate?
Bill, the L backplate provides the same function whether it's metered or day clock version as a standard 5600, but it does give a different appearance to the basic design. Also, from a service aspect, when you take a look at the exposure of the back cover assembly, the timer and the basic parts in back of the control valve are fully exposed and much more easily accessible.
Okay, and one other thing I should have mentioned is that I referred to the 12-day model and the meter model. We also have a 7-day skipper wheel model, so we can offer 12 or 7-day programming or the demand meter. Now we're going to take a closer look at some of the design options, and we're going to use some slides at this point. To summarize our design options, we'll begin with a view of the 5600 12-day control, which is a lead-in page in the catalog as well as a cover page for many of the service manuals that our customers use. It also resembles the ad which appeared in the trade magazines over the last 5-6 years when we advertised the 5600 series control. Here we have the 5600 meter control, trade named Econominder, catalog title page, and it is also resembling the ad which appeared in our trade magazines over the last 5-6 years. And it appears in this picture here, the standard housing without the cover. The 5600 main valve body design is illustrated here, and note we have our piston seal spacer parts group, we have our yoke option, And we have our injector drain module assembly, which includes a brine valve, injector throat nozzle and screen, injector cap, and the brine line flow control assembly. What's really convenient about the design of the 5600 valve body assembly is that it can serve either a 12-day clock model control or a 5600 meter control application. The body assemblies are completely interchangeable. Here we're illustrating the 12-day Powerhead assembly. The top half of the illustration, we're showing the parts that attach to the front of the clock case. The bottom half of the illustration showing all the parts that mount to the back of the clock case. About the only thing that you would service in the field on the Powerhead assembly or replace would be the motor assembly itself, and the electrical voltages that are available are 24 volt, 110 volt, or 240 volt. To point out another significant design feature in the 5600 control, we've cut away the clock case from the timer assembly in order to show you the side view of the three main gears on the back side of the timer. That gearing is all plastic to plastic, 3/8 inch thick, and it ties in with the feature we told you about earlier regarding the way the piston is designed. Remember, the hole in the piston equalizes pressure throughout the valve body, which makes it easier for the control to transfer into regeneration. Well, the thickness of the gears that we have chosen to go with here, really we're about 3 times thicker than we have to be, because we really don't need heavy-duty gearing to transfer that workload from the motor, because of the fact we've equalized pressure in the valve body by drilling that hole through the length of the piston. But we do this because many times people will comment that they believe the valve is of superior design mainly because we made the gears thicker, which in their mind makes the gears stronger and less likely to crack. But really the story begins way back with the design of the piston equalizing internal pressure in the valve, which makes the job so much easier for these gears to function without breaking. This is the 5600 meter economizer Powerhead assembly, and it bears many resemblances to the 12-day Powerhead that we just looked at, but the main differences are our meter program wheel, and then our cable and clutching assembly. And oftentimes the question is asked, can we rebuild a 12-day clock housing into a meter clock housing? And the answer would be no, because notice we do have a pinion that must come through the front of the clock housing in order to drive our meter program wheel. So if you started with a 12-day clock housing, you wouldn't have the proper face label on the control to accept the meter feature. Also, our instructions over in the left-hand corner on the label for setting the clock are a little bit different for the meter control versus a 12-day control. Our bypass valve illustration reminds us that the internal plastic plug, which is located within the rubber boot, is the moving part. There is no in-stream moving part, which is the main design feature of the control, in that the valve may be in service or bypass position for an extended period of time, but we don't have to worry about it becoming stuck permanently in that position, because when we do transfer it to the other mode, the part that moves is actually out of the stream of water. This slide kind of summarizes the options that are available on the plumbing end of the control system. Here we have a 3/4 inch bypass that's also available in 1 inch. In this particular model is nickel plated. Then we have the 1 inch and 3/4 inch brass yokes. And here we've got the brass, either 3/4 or 1 inch bypass. We're often asked the question, why would somebody nickel plate a control? And I think that there's a couple of reasons. One is appearance. Secondly, if it's nickel plated, there's less chance for the brass to oxidize and turn the valving dark green. So if you're renting equipment, you may be interested in nickel plating the main valve assemblies, because they're a little bit easier to maintain if you have to pull a unit and clean it up for reinstallation in another home. Here we show the 2 basic color combinations that are available in the face labeling on the control. On our 12-day model, we've got the black label with the silver blue pinstripe trim. We also offer a beige label with a brown and an orange trim. On the meter control to the right, this is the trim that has been advertised in the trade magazines over the last 4 to 5 years. It's probably the most popular trim color, the orange, beige, and brown. We also have the silver, black, and two-tone blue. And then we also have covers that fit the face front in beige, blue, or dark gray.
When training a new serviceman, the easiest thing to do is to show the man how to take things apart and put it back together. The most difficult time comes when he has to go to that first job site and analyze what the service problem happens to be. When we were training service people back in a dealership I was involved with, we came up with kind of a mental checklist referring to 4 letters, BTTB. When a serviceman would come to the job site, he would set his tools down, repeat those letters, and then start a systematic approach to servicing. The first letter, B, is check the bypass. Many homeowners like to play around with bypass valves. On the 5600 valve, when the handle points straight back towards the pipes, the unit's in the service position. When it's rotated 90 degrees, you're in the bypass position. The difficult time comes is when you have a 3-hand valve bypass, where you have the 2 valves on the inlet and outlet valve and the interconnecting bypass valve. Again, homeowners like to play around with those valves. It becomes very difficult for them to get them in the right pattern. The first T that we come to is test the water. Test the raw water for hardness and iron content, and compensate for the iron that you have in the water. An example of this would be 20 grain water and 3 parts per million of iron. Each part per million of iron consider as 4 grains of hardness. So for this example, the 3 parts per million equals 12 grains of hardness plus the 20 grains of hardness from the original check. So we would want to set the equipment up for 32 grains of hardness. Also have the man check the hot and cold condition water. The hot water heater in any plumbing system tells you something that happened a few days ago. A 40-gallon hot water heater takes 80 to 120 gallons of usage to flush out from hard to soft or soft to hard. And this is telling you something that has happened a few days ago. Let's say you go to the job site, remove the cover off the timer, take a look, and the unit recycled last night. You check the cold water that comes directly out of the water conditioning unit. It's 0 soft. You check the hot water, and possibly it could be 15, 14 grains hard on that 20 grain hardness example I gave previously. The unit is going through the cycles, but for some reason it's not keeping up from cycle to cycle. Let's say you go there and just the opposite is happening. You take a look at the timer assembly, and the unit's going to regenerate tonight or possibly tomorrow night. Again, checking the cold water right out of the water conditioning unit, you may have hard water. Checking the hot water heater, again, it may not be total hard or total soft, but something in between. Again, an example of running short of capacity. The areas that I used to work running short of capacity primarily ran into toilets running. When you lift the back of the toilet tank off and look where the overflow is, if that level of water is right near the top or dribbling over into the overflow at, let's say, a pint a minute, that's like adding an additional 172 gallons in a 24-hour period. Whether it's a day clock or a meter type version, you never set the program up to compensate for that. Also, I would have calls right after the holidays, 4th of July, Thanksgiving, New Year's, Christmas, where again, you set the equipment up for 3 to 4 people in the family, but now for the holidays, you have 20, 30 people over using the conditioned water. Additional people in the family could also mean small infants. A small infant uses just as much, if not more, conditioned water as an adult, with the additional washing that's involved with the clothes. The next T is checking the timer. The timer on a water conditioning unit is just like an electric alarm clock. If you don't have the current time of day set, your alarm time is going to be off. If the alarm time or regeneration time on your water conditioning unit is, let's say, regenerating at 6, 7, 8 o'clock in the morning, the time when people are getting up and taking showers, internally the control valve bypasses hard water to the system. During the showers, you're putting all that hard water into the hot water heater, and again, taking 2 to 3 times its usage to flush it out will probably take until the next regeneration, until that hot water heater is back in a softened position. But then again, you're regenerating and you're producing hard water on a continuing type basis. Units that are installed in basements where they've redone the basement into rec rooms. Many people who do their rec rooms like to rewire the basement so when they go upstairs and shut the lights off, they also shut all the power off in the basement, also shutting down the water conditioning unit. That timer will be off, and when you go down there turning the lights on, you'll energize and you'll think something has happened to the, let's say, the timer or the outlet circuit. But making sure you have a live outlet at all times. Also plugging into pull chain sockets, make sure again that you have a live circuit at all times. The other thing, checking with the timer, those of you who use 24-volt systems and your outside or inside transformer, step-down type of transformer, you may have to use a probe light, probe tester, circuit tester to check to see that you have a live circuit going into your transformer and also a live circuit coming out of the transformer, energizing the unit. The last letter, B, checking the brine tank. For the most obvious, checking for salt. But also, when you do check for salt, looking and seeing that the salt level is always above the water level. Once the salt level gets below the water level, your concentration of brine is greatly diluted. You're basing all your regeneration capacities, whether it's day clock or metered equipment, on 100% concentrated brine. So salt level is very important. Also, when you do come to the unit, the brine tank, and lift the lid off, you'll see one of 3 conditions in the brine tank with the water level. Either the water level will be extremely high, very low, or normal. Let's say you hit the first condition. The water level in the brine tank is extremely high. Looking at the back of the unit, the only way water can get back into the brine tank is if this poppet valve right here is pushed open. When you push that open, water goes back into the brine tank, and when it's done filling on a time brine basis, that poppet valve has to snap shut 100%. If for some reason, some foreign material or through wear and use, the valve does not 100% shut off, water will continue to drip back into the brine tank. The water level will get higher and higher. To check for this very easily, with the unit in a service position, disconnect the poly tubing at the brass fitting here or in the brine tank. No water should be coming out of that fitting at all. If you get a constant drip or water leaking out, you know that that brine poppet valve is the key thing to key into. Also, on all time brine refill units, whenever a unit goes through its regeneration cycle and you don't draw all the brine solution out of the brine tank, the unit doesn't know it and it still puts more water back in. That area, key area to check, would be in the injector area, which will be right underneath this cap assembly. Let's take a look at the second condition if you had low water in the brine tank. Again, the only way water can get back into the brine tank is if that brine poppet valve, that spring-loaded valve, is pushed open. When that happens, line pressure goes into this brass fitting right here, and inside that brass fitting is a small rubber washer. That controls the water back into the brine tank at a certain flow rate, either a quarter, a half a gallon a minute, or 1 gallon a minute. If for some reason that small rubber washer becomes partially plugged up with foreign material or whatever, it's not going to allow the water to go back at the correct flow rate. The timer times itself out, and your liquid level will be much lower than what you normally had set it for. The third condition is the most difficult one because you've checked the other items, the bypass, the additional people in the family. In this instance, I would tell the man now to take the cover off the unit and to start cycling the unit through. cycle the unit into the backwash position. In this position, you should hear a high flow rate coming to the drain. Advance it to the brine and slow rinse position. In this position, the flow rate at the drain should be greatly reduced, probably 1/3 to 1/2 gallon a minute. Advance it a little bit further into the rapid rinse and settling rinse positions, and again, you should hear a high flow rate running at the drain. High flow rate, low, and high flow rate are normal cycles of operation. If for some reason that the flow rate at the drain never changes and remains constant, then is the time to check where the discharge is going from the water conditioning unit, whether it be polytubing, PVC, solid copper, or galvanized. Make sure there are no restrictions at that end discharge point. If you're using polytubing, follow the polytubing back if it's through the floor joists or behind various appliances, and make sure that there's no restrictions in the tubing assembly. And then follow the drain all the way back into the drain port. At this time, if there are no restrictions, we'll take a look a little bit later into the drain port and show you what to take a look at. BTTB, 4 easy checkpoints, at the most will take you 5 minutes to check out a unit, but it'll key you into over 2/3 of your service calls. What many people use in the brine tank as a safety feature is a safety brine valve backup type system. In the BTTB, you notice that one of the key areas was the brine valve. If that happened to, let's say, leak and not 100% shut off, or if the injector assembly got plugged up and didn't draw the brine solution out, we will continually put water back into the brine tank. The safety brine valve feature is shown here inside the brine well, will help prevent brine tank overflows. In this photograph here, we're showing an old style air check that goes back many years ago, but many of them are still in the field. The float assembly, preset a few inches above what your normal water setting would be, and just below the overflow in the brine tank. A close-up view of the safety brine valve, the brass body assembly, shows the simplicity of the safety brine valve. As the water level starts increasing in the brine tank due to a leaky brine valve, or let's say an injector assembly plugged up, the float assembly will start rising up, allowing the ball inside the brine valve to drop down and shut off and stop any additional flow. The service call then will be basically hard water or salty water, because too much water is in the brine tank, dissolving too much salt. But one of the key things in working with the brine valves, safety brine valves, is the location of these rubber grommets. You should always have approximately 1 inch space between the rubber grommets where the arm assembly comes out. If those rubber grommets are pressed together, when the water level starts increasing, instead of the float assembly rising straight up, it'll come off to an angle, hit the side of the brine well, and not shut off as it was designed for. The other thing to watch for when working with a safety brine valve is the location of this PVC tube in relationship to your brine well cap on top of it. You should always have that tube assembly down far enough so that when the water level increases and the brine float system rises, it doesn't hit the top cap and again prevent it from shutting off. The 500 air check has been around for a number of years, and we're approximately in our 3rd generation. As you noticed in the original photograph of the safety brine valve assembly, you had kind of a J effect for the the air check assembly. That J air check assembly has been around for since the mid-60s. The next style that we went to is what's pictured here, and that has been around for approximately 5 or 6 years. And we did have a problem periodically with what's called pre-checking. You would cycle the unit into the brine draw cycle, and about a minute or 2 into brine draw, the ball assembly would come down and pre-check before all the brine solution was drawn out. To prevent this, we went into the 3rd generation of brine valve, in which we eliminated these vertical slots at the top And you'll notice on the current style air check, the lower slots are much wider, and as we get near the top, they start thinning out. This is to force the brine solution to follow the path of least resistance, entering in at the bottom of the air check and maintaining the ball up in the upper cage assembly until the level of brine has come down and the air check can check off.
Mike, I don't think we can emphasize BTTB too much, because what it really does is it forces a systematic approach. And when we use the systematic approach in servicing, we know that we're working smart and not hard, and we're going to keep the cost of that service call to an absolute minimum, and that's what it's all about. We want to put the dollars on the bottom line by handling the calls efficiently and in the least amount of time. So let's talk a little bit about setting timers. That's the next thing we want to cover. And let's take, for instance, a 12-day control first, which we have right here. The first step in setting the timer up would be to index the red pinion gear on the front of the timer, and then simply turn the 24-hour gear left or right until the current time of day appears in the window box below. The second thing we want to do is go to the skipper wheel, and we want to arrange the pattern of skipper wheel tabs such that the tab representing regeneration is the tab which is out away from center, and we want to have one of those tabs moved away from center for each day that we expect to regenerate. Now, the red arrow that you see on the front of the skipper wheel represents the next 2 a.m. and so if we had a tab out away from center opposite the red arrow, that would obviously mean we're going to have regeneration occurring tomorrow morning at 2 a.m. If we want regeneration every second day, we would have every other tab pushed out. Every third day, every third tab, and so on. The most popular timer control mechanism on the market happens to be the 12-day, because you can do more things with a combination of 12 skipper tabs. You could regenerate every day, every other day, every third day, or every fourth or sixth day. It's much more flexible than the 7-day wheel that we mentioned was also available as an option. 7-day skipper wheels are primarily popular in your commercial industrial applications, where they normally would regenerate a system along the lines of the pattern of the days of the week or the calendar. Okay, let's take a look a little bit at the metered control system and cover the regeneration setting procedure here. It's quite similar to the one we just talked about. We press in on the red pinion gear and we rotate the 24-hour gear left or right until the current time of day is in the bottom center window. Now, when we go over to the right side of the 24-hour gear, things are a little bit different here, because we have a program wheel, and there's one of two ways we can program a meter control. The first way we can program, which would be typical of a residential application, we would dial the hardness of the water that we tested in step 2 of the BTTB formula and set it up opposite the number of people in the family. And we would do that by simply holding the base gear, which I'm doing with my right index finger, and then pulling out on the dial and turning the dial left or right, lining up the hardness, which is on the inside label, with the number of people, which is represented on the outside label, numbers 1 through 7. Now, when we have 24 grain hard water and let's say 4 people in the family, we would dial 24 opposite the 4 people and then index the program wheel all the way counterclockwise until it stops, and then simply manually rotate the main dial in the front 360 degrees. And that arms the program wheel so that it's at the beginning, the proper beginning spot for that combination of hardness and family size. Now, the second way we can program a meter control is a method that would be commonly used in commercial and industrial applications, and that's where we program in terms of gallons between regeneration. Now, obviously, with no family size to make reference to, that would seem like the natural thing on most industrial commercial applications. So just picture this program wheel without a people label or the outside dial or the hardness label, which we used to orientate with in the first example. Now what we would do is calculate how many gallons of capacity the unit is going to give us with the salt setting that we have. For example, let's say we had a cubic foot unit, 24 grain hard water, and let's say we were brining it at 8 pounds of salt. Well, that would yield 24,000 grains of capacity, or 1,000 gallons. Now, if the business that we had the unit installed in, for instance, was a restaurant and they used an average of maybe 300 gallons per day, we would subtract 300 gallons from the available 1,000 gallon capacity and call that reserve. And then take the 700 gallons remaining, or the usable supply, and we would simply, again holding the base gear, pull out on the program wheel and line up the number 700 in the gallon label, which is the outer label, opposite the white dot on our wheel, and that would tell us that we're now programmed for 700 gallons between regeneration. But as in the case of the first example, we always have to orientate the program wheel to the current time of day. So we would turn the wheel all the way to the stop point counterclockwise, and then manually index the main gear, bring it back to the service position, and the program wheel would be ready to go. Okay, let's say we wanted a manual regeneration because we were expecting company in the case of a residential application, or let's say in the case of that commercial application we just covered, we had an extra busy day at the restaurant. In order to get the manual regeneration, we would simply turn the manual knob approximately 2 clicks, and we should be able to read the word or the abbreviation regen in the cycle position window, and at that point we can walk away from it and the unit will regenerate automatically. The timer motor will engage the gearing and it will bring our main gear all the way around, and the unit would regenerate at whatever time of day we might initiate it. Now typically the controls are set up at the factory for a fixed 2 a.m. regeneration. In other words, on a 12-day model, we said the red arrow on the skipper wheel indicated the next time at 2 a.m. that the unit would regenerate if the tab were moved away from center. In the case of the meter control, we always have a reserve capacity to take us from the time of the day that the meter wheel zeroes out until the next programmable, or the next programmed regeneration, which is going to be at 2 a.m. But let's say for some reason we don't want a 2 a.m. regeneration. For instance, let's say it's a business where there's always water being used at that time of day. Or let's say in the case of a residence, the man of the family works, gets home at 11 o'clock in the evening, and maybe doesn't go to bed right away, and he maybe showers at 2, 3 in the morning, typically. Well, what we can do is show you how to have that unit regenerate at a fixed time of day other than 2 a.m. We'll get into that with our slides a little bit later on, but it is possible to have the timer field adjusted so that it can regenerate consistently at some other time of day than 2 a.m. And we'll demonstrate that when we use the slide set in just a few minutes.
Also, Bill, when you were talking about reorientating the regeneration time, you're taking into account that you're keeping the current time of day setting so that you're not offsetting that time, let's say cheating the clock more, so to speak, by 6 or 7 hours just to achieve some other item. You can still keep the current time of day and reset it back to a different regeneration time.
Okay, now we're going to take a look at one other setting that's important on the controls, and that is the brine gear on the reverse side of the control. What we can do as far as the versatility of the regeneration is going to be determined by the salt scale. Now there's 2 different labels available. There's a 3 to 18 pound salt scale, which simply tells me that the brine line flow control button is refilling the brine tank at a rate of 1/4 gallon per minute. Or the second scale that we might run into on a control would read 6 to 36 pounds, which would tell me that we have a 1/2 gallon per minute brine line flow control button. Whichever label we have, we must select a position for the white lobe pointer so that we know the volume of salt used per regeneration. Now, how much salt should we use? Well, that's a question really of how much resin or capacity by volume there is in the tank. For instance, in our example of a cubic foot unit, Let's use 8 pounds since that's a fairly universal medium salt setting. With 8 pounds of salt, we would recover 24,000 grains of capacity, and all we'd have to do is loosen this center screw and make sure that our brine lobe, the white lobe pointer, ends up on 8 pounds. And then retighten that screw, and every time the unit comes around during regeneration, the refill poppet valve will be open for that amount of time that allows enough water, which will dissolve 8 pounds of salt, to enter the brine tank. Now, if we wanted to change this, we have to be very careful in the case of demand regeneration systems, because when you cut a salt setting, you're really reducing the capacity of that unit in terms of recoverable capacity, and we generally never want to reduce a salt setting on any type of demand system, because the meter, in our case, is programmed for the number of grains of capacity that the original volume of resin the manufacturer put in the unit and the original salt setting that the manufacturer put on the unit. If we cut that salt setting, we'll come up with some volume less than 24,000 grains, as we're using in our example. And conversely, you should not just arbitrarily increase the salt setting, because if you do that, the unit's going to regenerate as though it only had 24,000 grains, and now we'll be wasting salt, and the homeowner won't be very happy with that. So the moral of the story is the manufacturer sets the salt setting knowing how much resin is in the tank, and we should understand what the relationship is between the salt setting and the volume of resin and what capacities those yield. But we don't want to arbitrarily make those changes unless we are doing it for a good reason. And there are reasons that we will want to increase salt settings. There are reasons where we may want to decrease. If you had some of the examples that Mike referred to before on an application, let's say an RO unit that was using water at a rate less than what the meter registers, in a sense that would be similar to having an additional person in the family, because it's using water every 24-hour period, but the meter isn't counting it. So we're understating the actual amount of water used relative to what was, and we may want to increase the salt setting 1 pound or 2 pounds to compensate for something like that. In the case of cutting the salt setting, usually you wouldn't want to reduce the salt setting for any reason unless you had extremely low hardness in the water and we were close to the maximum gallon setting on the meter, which is 2,150 gallons. In that case, we might want to cut the salt setting from, let's say, 8 pounds down to 6, knowing that 6 pounds of salt with a cubic foot of resin would give us about, maybe 20,000 grains of recovered capacity, and let's say we had 4 or 5 grain hardness of water. And so we're going to end up, we would cut the salt setting to compensate for coming up with some gallon program close to the maximum 2,150 gallons. And that's about the only thing I can think of, unless, Mike, you can think of something, some other reason why they might want to cut a salt setting. But generally, demand systems don't cut the salt setting.
If I can just break in a second. The meter settings that Bill was talking about, whether you use gallonage or people versus hardness, the two should complement each other. If you had 1,000 gallons of water available per regeneration and you built a reserve capacity for 4 people of 300 gallons, that 700 gallon setting should relate to the people versus the hardness type setting, and the two should go complement each other back and forth.
Here we've got a 7 or 12 day program timer, and what we're going to talk about here is how to program the frequency of regeneration on the skipper wheel, how to set up the current time of day. Here we've got 12 a.m. set in, the callouts for the cycle position the valve is in at the present time we're in service, and the procedure for working with these 3 variables is outlined in the lower left-hand corner. To set time of day, press the red button and turn the large gear, our large 24-hour gear, left or right, until the current time of day is in the window at the bottom above the triangle. Second thing we want to do is determine the frequency of regeneration with each tab representing a 24-hour time period. And for those days that we want a regeneration, beginning with the next day at 2 a.m., we would slide those tabs out away from center. If it's every other day, we would slide out tab 2, 4, 6, 8, 10, and 12. Any frequency of every day, every other day, every third day, or every fourth day, every sixth day, or maybe every day is attainable with a 12-day wheel, and this is the most popular wheel for residential applications. When we designed the meter option for the 5600 valve, we took a look at what was on the market in the way of demand regeneration systems, and we came to the conclusion that ours would have to be the ultimate in simplicity as far as programming. We wanted to have a design that would not require any manuals for looking up values, for imputing into the face of the timer. We wanted to make sure that it wasn't overcomplicated through the use of electronics or extra electric assemblies. And the final product actually ended up being a procedure: set the time, set the hardness. And we can illustrate that with this slide. Setting the time in the same fashion as a 12-day timer, pressing on the red button and dial the current time of day in the window below the manual knob. Then going over to the program wheel, although some of the numbers are fairly small and we cannot read all of them, we will pick up a close-up view of this dial on the next slide. What we do over here, as we illustrated earlier, pull out on the spring-loaded center wheel and turn the center wheel left or right, lining up the hardness of the water, compensated for iron if necessary, opposite one of these numbers, 1 through 7, representing the number of people in the family. And after aligning the hardness and the number of people in the family, releasing the center wheel, and then rotating our entire program wheel to the left counterclockwise until the pointer comes to a stop position over at the 270-degree position of the 24-hour gear. And at that point, you'll recall we simply turn the manual knob in a clockwise direction 360 degrees, and that arms the program wheel to the proper start position. Our instructions for programming the meter control also appear in the lower left-hand corner, so they're very handy for reference at any time. Here we're looking at the meter program wheel from a meter powerhead assembly. Our gallon setting indicator is simply a white dot on the base gear. Our K hardness label, we're referring to this smallest center located label with the values of 10 through 100 representing grains of hardness. Little code right over here, 24K cap, abbreviating 24,000 grains of capacity. And then the next label we want to mention is adjacent to the hardness label. It's called the people label with numbers 1 through 7. The distance between each one of those numbers is approximately 75 gallons, which also is the average amount of water used per person per day. That we'll see a little later on comes in handy for programming additional capacities. The last label we want to mention is the one on the outer perimeter, the gallon label. In this case, it starts at about 225 gallons, goes all the way around up to 2150. The highest value we show is 2100. Now there's two ways you can program a meter control. On residential applications, as we said earlier, set the time and set the hardness. On light commercial and industrial, we can remove the hardness label and the people label and simply dial in the gallon setting indicator opposite the number of gallons that we want the unit to pass prior to regeneration. In this example, we have 700 gallons net capacity or usable capacity programmed on the wheel. The way we would calculate that, since let's say we have a cubic foot unit, and let's, for simplicity's sake, say we've got 24 grain water, we'd have 1,000 usable gallons each regeneration. We would want to deduct a reserve capacity, let's say 300 gallons, and arriving at the 700 gallons, the remainder that we program in opposite the white dot. We get this setting of 700 opposite the white dot in the same manner that we program hardness and size of family. Simply pull out on the center spring-loaded wheel, turn the dial left or right until we get the gallon setting indicator opposite the number of gallons we want to program. Here we're illustrating the parts group from the manual knob assembly on the front of the timer assembly. And if we were to take this tape decal off the center of the manual knob, there would be a screw mounting right in the center. And by removing that screw, we could disassemble the mask and the cycle printout disc and the 24-hour gear. We might want to do this in the case of, let's say we've got a situation where a 2 a.m. regeneration is not desirable. If we disassemble the timer manual knob assembly and get access to the 24-hour gear, we can lay another label down right on top of the label that's already in position on the 24-hour gear. And let's say, for instance, we wanted to have the unit regenerate at 6 a.m. every morning. We would take that new label and line up the 6 a.m. right on top of the 2 a.m. and then stick the label down in that position. What we've done is we've offset the timer 4 hours, and then we just reassemble the assembly and then dial in our current time of day, and we have in effect cheated the timer by 4 hours by mislocating the label intentionally, the 4-hour interval. Here we're illustrating the rear view of a 12-day program timer assembly, and there's many things we can comment here on. Our motor assembly, we have a little sight glass, and this is how we tell if the motor is good. We must see that rotor turning through the sight glass window before we can be assured that the motor is a good motor. Remember, if it's only warm, that doesn't tell us anything about whether or not it's able to operate. We have to see the rotor actually turning. Then over here, our salt label. There's 2 different label values, 3 to 18 pounds and 6 to 36 pounds, and the scale that we would use would be directly related to the brine line flow control label down here, either a 1/4 gallon or a 1/2 gallon per minute on the refill rate. Then we can see into the drain line connection, and we see the drain line flow control button and also the retainer which threads in the 4 openings there, and that retainer simply keeps the button standing on edge vertically in there so that the only water passing through is going to come out the center opening. We have every motor that's date coded with a 4-digit number. The number 2144, for example, would represent February 14th, 1984. And we decipher that by taking the first digit, which is a 2, represents the 2nd month of the year. The middle 2 digits, the 14, represent the day of that month the motor was made. And the last digit, the 4, is the last digit in the year. Again, that would be February 14th, 1984. Now, because we've got a situation in the 4th quarter, the months of October, November, and December, where we only have a single digit to represent months, we use the letters X, Y, and Z to symbolize October, November, and December. So if we had a code Z144, we would have December 14th, 1984. Deciphering that code, which is stamped on the motor cover, is important to you because there is a 36-month warranty on the motors, and it would be 36 months counted forward from the date of that date code. This slide looks very similar to the preceding slide, except here we're illustrating our meter assembly, meter cable, and the clutching assembly, which is mounted into the back of the timer. All of the other parts on the back side would be very similar in design to the 12-day program timer. This illustration is very, very important in applying the control properly. We've got our brine valve assembly and our brine gear assembly. The value that we have our brine refill lobe dialed to, in this illustration it's on numbers 18, indicating 18 pounds of salt with that setting, really determines if the system's going to work right or wrong or marginally. If we have too much salt, we're wasting the homeowner's money. If we don't have enough salt, we could be in trouble if it's a meter control system, because it's going to be regenerating 1 day too late or 2 days too late because we're not creating enough capacity with an insufficient salt setting. So the best thing to remember is let the manufacturer be responsible for setting that salt setting, and let's not increase it or decrease it without having some valid reason for doing so and knowing what we're going to get if we increase or decrease. And because that's such an important aspect of the operation of the control, we're going to look at the salt curve on the next slide. We're just going to review what kind of capacities you can expect on a hypothetical conditioner with various salt settings. And that hopefully will keep you current on what capacities you can expect with various salt settings and various size systems that you're working with. Speaking of capacities, let's take the example of 1 cubic foot of resin with what we'll refer to as a full salting condition. We're going to use 15 pounds of salt to regenerate that cubic foot of resin and come up with a capacity for that cubic foot of 30,000 grains. If we have 15 grains per gallon hardness level in the water, we'll end up with 2,000 gallons of soft water. If we raise the grains per gallon to 20, obviously we end up with a lesser amount, or 1,500 gallons of soft water. The point here we want to remember is that a 30,000 grain softener is only a 30,000 grain softener if it has the cubic foot of resin salted with 15 pounds. If we have an 8-pound salt setting on this softener, we would only have 24,000 grains recovered and far fewer gallons when we divide 24,000 by the 15, or in this second example, 24,000 divided by the 20. Here we're illustrating the effect of various amounts of salt used to regenerate a cubic foot of resin, with our vertical scale being grains of capacity recovered in kilograins, and the horizontal scale representing pounds of salt to regenerate. For example, if we used 15 pounds, the full salting condition that we just referred to, we would come out at about 30,000 grains recovered per cubic foot. If we used a smaller amount of salt, such as 8 pounds, we would come out in the neighborhood of 24,000 grains. And if we used an even lesser amount, such as 6 pounds, we would be in the neighborhood of 20,000 grains, and that's all per cubic foot of resin. So as we vary the amount of salt, we vary the amount of capacity recovered, and therefore we vary the K label required on the front of the meter program timer wheel. So there has to be compatibility between grains recovered at regeneration time and the little code on the K label on the front of the meter program wheel. This slide we can use to show two things. The first, what is the most economical salt setting? Well, if we use 10 pounds versus 15, we would recover 25 rather than 30,000 grains. From an operating standpoint, the 10-pound setting is more practical, because if we go from 10 to 15, we're using 50% more salt, but we're only getting 20% more capacity. And over a period of a year, that would be bad economics for the owner of the water conditioner. What we want is a trade-off between economy and operation and the conditions that you're working with, namely the hardness of the water at the job site. The most common setting, medium salt setting as it's referred to, is 8 pounds per cubic foot. And that makes a good salt setting in areas where maybe the hardness runs anywhere from, let's say 10 up through 20, 25 grains per gallon. When we get in extremely hard water, then we're going to want to go towards the 15 pounds per cubic foot setting, especially if there happens to be iron in the water along with the high hardness levels. The reason for that is we want to protect against bleed through when we get near the end of the capacity of the bed. We want the full capacity that's in there to be working for us, and because our hardness is so high, just a little bit of bleed through could possibly give us 5 or 6 grains near the end of our capacity in that unit. The second thing the chart serves us here, its purpose in, is to show us that if we go to 20 pounds or double the amount of salt from 10 to 20, we're getting a very poor increase as a result of it. We're only getting an additional 8,000 grains. So when I used the term full salting before and said it was 15 pounds, it was only for the reason that the curve that we saw in the preceding slide has a slope characteristic such that you really don't get any economics out of additional costs for salt in terms of what you're recovering in grains capacity. So it would be kind of foolish to have a salt setting in excess of 15 pounds per cubic foot under any conditions. Okay, this final shot here of the salt curve brings home the point we just made of 3 different salt settings. Notice the position on the curve. Our full salting is almost at the point where the curve is peaked out. 10 pounds, quite a ways down the slope. 6 pounds, way down at this point. Now, if we divided the grains of capacity recovered with each salt setting, we would find 6 pounds being approximately 20,000 grains, we would have over 3,000 grains per pound of salt. That'd be a good recovery rate in terms of grains recovered per pound. But if we did the same calculation at the 15-pound level, dividing 30,000 grains by 15, we only have 2,000 grains recovered per pound of salt. So we have a difference of 50% in the operating cost of the unit, 6 pounds versus 15 pounds per cubic foot. Now we're going to take a look at the cycles of operation of the 5600 control. And right now we're illustrating the service position. In the service position we have water coming into the inlet of the control. And it comes down into the top of the tank on either side of the distributor tube, filters on down through the resin and into the bottom opening of the distributor tube and up the tube, out the outlet of the control. When we've used the full capacity of the resin bed based on the hardness of the water, the control either regenerates in response to the skipper wheel setting on a 12-day clock or the meter, which has registered the water as we used it during the service cycle, and a regeneration begins. The caption along the bottom of this drawing is simply explaining the operation of the cycle, and in the service manual that comes with the control, it is a handy reference item in servicing the control, whatever cycle of operation it may be in. All we must do is just read the caption on the bottom of that particular cycle, and we'll be tracing for ourselves the flow, direction of the water, and it's fairly simple to track down why the control is not functioning properly in terms of the directions given to us from the caption and the arrow highlights in the drawings. Okay, the first thing that happens when we go into a regeneration sequence is we go into what we call a preliminary downflow rinse, and the duration of that cycle is approximately 5 minutes. There's 8 cycles in all that we're going to talk about, and think in terms of the first 4 occurring as the piston travels down through the valve, and the second 4 occurring as the piston is returning back to its upward position. So if that's the movement pattern of the piston, the time cycles for each of the cycles on the down side have to be exactly the same number of minutes as the cycles on the upside of the piston movement. The only difference is when the piston is returning back up to its service position, the cycles occur in reverse order. So in this cycle, where we're preliminary rinsing down, the water is actually flowing in the same pattern as it would be in the service cycle. It comes down through the resin, up through the distributor tube, and out the outlet. Okay, the preliminary downflow rinse cycle is followed by the backwash cycle. Duration of this cycle is 10 minutes. The function of this cycle is to bring water in the inlet of the control, down through the distributor tube, out the bottom, and up through the bed. Notice that we're flowing in exactly the opposite direction as we did in service and preliminary rinse. The purpose again is to lift the bed up so that any trapped particles on the top of the bed are now rinsed to drain, And basically we're preparing the resin bed for the following cycle, which is when we're going to draw the brine in to recover the capacity of the unit. Notice over here in the brine tank our liquid level stays the same because we haven't started to draw the brine yet. All that we're doing is expanding the bed, lifting out all of the trapped solids that are on top of the bed, putting them down the drain. Following backwashing, we move into the brine cycle, which is a fixed 50-minute time setting, and we also combine within that 50-minute time frame what we call the slow rinse cycle, which will be illustrated on the next slide. But notice up in the valve, what we're doing is we're sending water at inlet pressure through the injector screen up into the cap and back into the injector nozzle, where it's allowed to create a vacuum to draw the brine from the brine tank. Notice our liquid level in the brine tank is now down even to where the ball check is sitting on the seat in the valve. So we're going to draw until the ball gets to the position it's in, and we draw there because of the vacuum that's being created by the injector assembly. Now when the ball check seats in the air check assembly, what happens is the injector continues to be fed inlet water, and that's known as our slow rinse cycle. The next illustration, we'll notice the direction of flow will be exactly the same going through the bed as in the brine draw, except we are not sending brine through during the slow rinse, we're just sending through rinse water. And the number of minutes of that 50-minute cycle that we are actually drawing brine ends up to be in the neighborhood of maybe 14 to 17 minutes, or approximately 1/3 of the 50 minutes. The remaining 2/3 would be the slow rinse cycle. And we keep that proportion of 1/3 brine time, 2/3 slow rinse by the injector that we recommend that you use on the various size units. Our slow rinse cycle is appropriately named for the balance of that 50-minute time increment, the last 2/3 of the time, because it reminds us that we want to rinse the salt out at a very slow rate. Since the brine is a heavier liquid, it's going to have a natural tendency to gravitate towards the bottom of the resin tank, and that fresh water, which is coming in during the slow rinse cycle from the top of the tank down, we want it to come in at a rate slow enough so we don't disturb the bed. If we were to send it in at a very rapid rate, we might churn the resin in there, and it would disturb the stratified manner in which the brine is being rinsed out of the resin bed. Also, by bringing the brine in following, preceding the slow rinse, and then following with a very slow flow rate through the bed, we're using the least amount of water to get the salt out of the resin tank. Therefore, we're saving the maximum capacity for the next service cycle. So we want to accomplish the rinsing of the salt with the least amount of water, thereby preserving the maximum amount of capacity which we just restored to the resin bed. Notice over in the brine tank, nothing has happened yet. Our air check ball is still down in the very bottom of the air check cage, and nothing can happen until 2 cycles from now when we refill the brine tank, getting the brine tank ready for the next regeneration to follow. Now we're entering the rapid rinse position, which is another 10-minute sequence, and that we can relate back to our backwash time when the piston was coming down through the bore of the valve. That first 10-minute increment was the first backwash cycle. Now we're on the upward movement. We're past the midpoint of regeneration, and the piston lobes are now passing the midpoints of the spacer, which allows our backwash or rapid rinse after regeneration. So the piston is just moving in the opposite direction, driven by the same motor speed. Therefore, we have the same time increment of 10 minutes. And what's happening here is we're coming down the distributor tube, lifting the bed a second time. We have already changed the physical size of the resin beads because the brining has been completed. The beads actually shrink in size after they've been exposed to the sodium in the brining cycle. So if we were, for instance, in an area where there was iron in the water, we may find the surface of the resin beads coated with iron, and because the bead physically shrinks about 10% in size due to the brining cycle, we have a second opportunity to rinse out some of the iron that may have been adhering to the surface of the bead as a result of that bead against bead abrasive action that we get in the second backwash. If you were on, for instance, water with 2 parts per million of iron, if you observe the color of the water going down the drain during this cycle, you would see some evidence of color throw, indicating that we are effectively removing some of the solid iron from the surface of the resin beads during this cycle. This is a feature that is not in any other controls on the market, and it is a very effective way to get residual iron off the surface of the resin bead. In our settling rinse position, which is a 5-minute duration, this is the counterpart, as far as the cycle setting time, to our original preliminary downflow rinse. Notice the pattern of flow is identical. We come in the inlet of the valve, down through the tank, into the bottom distributor, and up out the distributor to drain. The function of this cycle is, since the preceding cycle was a backwash cycle, the bottom of the bed was serving as a filter. So if we were in water that had iron in it, as we were backwashing in the preceding cycle, we may have been trapping some of that iron on the bottom of the bed. So we want to back that cycle up with this settling rinse position where we bring water in and purge that color throw that might be trapped on the bottom of the bed and send it down the drain before the unit transfers back into service position. This will assure us that Mrs. Jones will not have orange spots in her laundry on Monday. Our last cycle of operation in the 5600 downflow brining control system is a brine tank fill. Our inlet water coming in the inlet side of the control supplies both the injector so that it can find its way over and down into the brine tank, and it's metered by our little brine line flow control button, and water is allowed to pass through this cavity for the number of minutes that the refill lobe has pushed down on the spring-loaded brine valve. And if we were to draw service water during this cycle, the inlet of the valve would also supply a source of water to go down through the resin bed so that we would have conditioned water available if we chose to use any of the service taps during brine tank fill. And that completes the regeneration sequence for the 5600 control.
The injector drain module assembly for both the clock and the meter version of the 5600 are common to both controls. The injector drain module assembly also contains 4 key parts in the control valve and any type of servicing. When we get into it, I'll show you that it contains the injector, screens and jets, the brine line flow control, the brine valve, and drain line flow control assembly. And also I'll try to relate those things back to the BTTB and the general checklist in servicing. To get into the drain line flow control module, we have to remove these 2 cap screws. 5/16 nut driver, we'll take those out. Cap assembly will come off. Then grabbing towards the rear of the module and swinging out like a door, that a module assembly will come out in your hands. Thing that we're keying into first will be the injector assembly. The screens, the injector nozzle and throat assembly. Common problems if this area is, let's say, plugged up, will be salty water, high water in the brine tank, low capacity. The flow of operation, the water enters through this screen assembly, loops over the cap and into the white injector assembly to create the venturi and draw the salt solution out. If for some reason this screen becomes plugged up with sand, silt, sediment, whatever, that flow stream of water will not flow properly into the injector module and will not create the venturi and not draw the salt solution out. You can clean it with a toothbrush, muriatic acid, whatever, as long as it's a nice clear flow pattern. When you get into the injector assembly, you have 2 parts in any of our injectors. It's the throat and nozzle assembly. The nozzle is the first part you see and can be cleaned out relatively easy with a toothpick by just poking it into that area. We'll poke anything through and get flushed out when it goes into the regeneration cycle. If you did have to remove the injector assembly, it comes in 2 parts. The nozzle comes out first. And you'll notice as we take these parts out that they have a common color to them. Both our injector nozzle and throat assembly are color-coded to represent different sizes for different style and types of tanks. The type that we have here is a number 1 and handles 8, 9, and 10-inch diameter tanks. If you remember the colors of the flag, red, white, and blue representing 0, 1, and 2, also representing 0, your 6 and 7-inch diameter tanks, number 1, your 8, 9, and 10-inch diameter tanks, the blue 12-inch diameter tanks. We even go beyond that point, yellow and green, for 13 and 14 and on up types of tanks or sizes of tanks. But the key thing is both the nozzle and the throat assembly must match in colors. You cannot mix yellow and red, blue and white. White has to go with white, red has to go with red. When you reassemble them, you do not have to put any type of sealant on the threads, and all you have to do when you do get it into the position is just snug those areas up. The next area we want to get into is the brine line flow control, and that's that little rubber washer inside this brass fitting right here. If you remember under the BTTB when we got into the brine tank with low water level in the brine tank, I said the water had to go through this brass fitting and there was a small washer in there. That limits the flow back into the brine tank, and if it becomes plugged for any reason, that flow rate will be greatly reduced and the water level in the brine tank will be restricted. By removing that brass fitting and turning it over and taking a look into the back section of here, you'll see a little white cage and the rubber washer. Taking a paper or a toothpick or a paper clip, you can push that cage assembly out, and what we're going to be looking at is that little black rubber washer. That hole in the center can become plugged with foreign material. If it's partially plugged, it's not going to allow the water to go back into the brine tank at the proper rate, giving you again the low water level. Once that area is cleaned out, reassembly, there is a correct and incorrect position. Two sides to the rubber washer. There'll be one side that has a bevel in the inside hole with a bunch of numbers around the outside, and the other side will be blank, straight cut across. The white cage assembly, there is no top or bottom. And when reassembling, after you've cleaned that area out, take it so that the numbers face down into that cage, and then take your fitting and slide the white cage up, so that when you look into the back section here, you're going to see the bevel or the numbered side. This assembly is like a check valve. When we're flowing into the brine tank, the flow of the water is going in this direction and the rubber washer is pushed into the brass fitting, so it's controlled through the center. When we're in the draw cycle, the reverse happens. We're drawing in this direction and that rubber washer is pulled away from the brass assembly, and the brine can pass around the outside, through the four legs, and through the center unrestricted. So, putting it back into the control, lubricate this O-ring with silicone and rotate it back in and tighten it down. Also noting on the assembly here, there is a label, and it has a 0.25 gallon per minute refill rate. That'll correlate with the 3 to 18 pound salt setting that Bill had mentioned to you previously. If it had a black label, it would be a 0.5 gallon a minute refill and giving you 6 to 36 pounds of salt. Or it could also be a red label and it would be a 1 gallon a minute refill. But the label should refer back to what your salt setting was on that salt cam. The third area getting into is our brine valve, this spring-loaded poppet valve assembly. And as I mentioned to you before, if for some reason when this is done refilling the brine tank and it doesn't snap shut 100%, water will continue to drip back into the brine tank. Disconnecting the polytubing here, when the unit's in a service position and water starts leaking out, That'll indicate you have a defective assembly. To get into this assembly, it's just O-ring loaded. You just pull straight out, and that assembly will come right out. The key thing that you're looking for in this assembly is the rubber seat. As you push down in a spring, you'll see that half-moon rubber seat assembly. If there's foreign material underneath there, it'll cause a leak into the brine tank. Or, after a period of time, if it becomes worn, it also could leak back into the brine tank. The key thing, once you've inspected or replaced it, is taking a look inside the housing itself, because you'll notice that buried along with the black plastic is another black O-ring. If for some reason you have to take that O-ring out, replace it, or inspect it, you should never put the O-ring on the end of this assembly and try to reassemble it in this manner. If doing that, you'll end up rolling, tearing, or chipping that O-ring every time when you try to get it back into the module. So if that O-ring is removed, first thing you want to do is just lay it down in there towards the bottom. Put a little silicone on the bottom there. Put the brine valve in like so. Now you cannot push down, because what's going to happen is that poppet valve assembly will bottom out in that valve body and you won't get it to seat properly. You want to lay it in here and take your thumbnails on the sides and push down so that that shoulder of the seat remains flush with the valve body. If you don't have thumbnails or you have stubby thumbs, you can take a 1/2 inch Schedule 40 PVC, about 2 inches long, cut a section of that off. It'll slip over the spring assembly and catch the shoulder and also be able to push it in. If you don't have that available, you can take a crescent wrench. And again, you can open it up, just catch the shoulder and push it down. The last area to take a look at is in the drain assembly. And remember when I mentioned the last B in checking the brine tank, and when you cycle the unit through, and if there was never any change of flow at the drain, when you went from backwash to brining, slow rinse to rapid rinse cycles, and you checked the poly tubing all the way back and there were no restrictions, then getting into this drain module assembly. If you look way down in the bottom, you'll see that there's a plastic retainer with some slotted areas. You can take a screwdriver and catch those slotted areas and just take that fitting out. Or we also have a special tool, and I'll show you a little bit later here when we reassemble it. But that plastic fitting comes out like so, and there's a rubber washer, another rubber washer down at the bottom. Now we want to take a look at things that can get backwashed up into this drain assembly. I've seen pieces of wood, nuts, bolts, rocks. If they partially plug up that center hole section, it's going to restrict the flow going out the drain, and it's just like pinching off the drain hose. And your flow at drain is going to be greatly reduced. You also notice that there's a bevel and a bunch of numbers on one side. That bevel, again, we want to see the flow stream of water, and that's the way we're controlling it. The numbers that are represented on that rubber button, the ones that end in 0, they're a 3-digit number. And you'll see like a 150, a 200, a 240, or a 300 represent 1.5 gallons a minute, 2.0, 2.4, or 3 gallons a minute. And if that button has to ever be changed or replaced, always match up the numbers, because that flow rate is directly proportional to the size unit and the amount of resin that you have in the tank. Once that area is cleaned out, the numbers and the bevel down as you put it into that drain assembly, making sure when you stick it down with your finger that it doesn't flip over. Taking your retainer, and here's a special tool I told you about. If you happen to have it, fine. You can just stick it in the slotted area and tighten down that drain retainer. All we want to do is just snug it up. If we crank it down too hard, you can actually pinch off that rubber washer and restrict the flow and cause a back pressure on the injector assembly, and also cause problems with the functioning of the control valve for regeneration cycles. But again, the key areas, we have the injector, screen, and jets that have to be cleaned. High water in the brine tank, salty water. Plugged brine line flow control, which would give us low water in the brine tank. A leaky brine valve, if it didn't 100% shut off, again giving us high water in the brine tank. And in a drain module assembly, as we cycle the unit through, if there was never any change of flow at the drain, and we check the drain assembly, polytubing or whatever for any restrictions, getting inside here. Next area we want to take a look at is having to get inside the control itself, internally. There's only one of three conditions that have to exist that you want to get inside the valve for the seal spacers or pistons assembly that Bill mentioned to you previously. The first condition would be if we had a leak coming out the drain, the unit in the service position, and we had a drip leak or a constant stream of water coming out the drain assembly, either going into stationary tubs, a floor drain, or a sump crock. The second condition would be if we had water coming out this stem assembly. There's a seal in this white end plug that would cause a leak coming out that end. Or if you manually tried to cycle the unit from position to position and the piston froze and you couldn't cycle it, something has jammed up internally to the control. If any one of those three conditions exist, you have to get inside the valve. But if you have any problems due to salty water, low capacity, air in the lines, those are all external, and you would see then in the drain module assembly. Now let's just take a look if you did have to get inside the control valve. We have three screws that we have to disconnect. The first thing is our main drive unit where this green piston rod assembly is attached to. Take that center screw out. You notice there's a little washer. And then the two screws holding the power head to the actual valve body itself. You'll also notice as you're taking these screws out, these two that we're taking off first are much longer than when we tip this power head forward. The balance of the three screws that hold this plate assembly. It's just that the longer ones have to go through the power head and hold it into the plate assembly. You'll also notice that each and every one where these pressure points are, and we have to, let's say, have excessive amount of pressure to seal down, that we put brass inserts into the plastic and can use machine screws. We don't use self-tapping screws in this area. Those three screws come off, the plate comes off, and now what we do is just pull straight up and we pull the piston assembly out. What we're checking for if we have a leak to the drain is the outside of that piston assembly, that it's nice and smooth and Teflon coated with no nicks or scratches on the outside. If there was, replace the piston assembly in its entirety. If the piston assembly looks fine, lay it down to the side, and now we want to take a look inside the control and the seals and spacers that we have inside. The rubber seals in here, there is no top or bottom to. The same thing holds true with the plastic spacers. The rubber seals are like let's say, the rings on a car engine, a piston assembly in a car engine. When a car engine's oil rings start wearing, you start blowing smoke or blowing oil or burning oil. The same thing can happen when the rings on, or the seals on the stack assembly start to wear. Instead of sealing around this green piston assembly, they wear and leak out the drain. Suggestion is usually made, replace all of the seals and spacers as a complete assembly, because you don't know which one has worn and there's no sense taking a chance of replacing the incorrect one. Now, like I mentioned to you, there is no top or bottom. The only thing you have to remember, we start off with the rubber seal, and it's like building a sandwich. We go seal, spacer, seal, spacer. When we lay those down inside the valve body bore, you always want to take your finger and rub it around on the inside. because those rubber seals, as you lay them down there, have a tendency at times, the edges, to flip up. And when we get all those rubber seals and the spacers on the inside set just properly, and we put the piston assembly back in, you're going to find that the piston assembly will stand about 1/8 of an inch above the valve body if we've done it correctly. If we've done it incorrectly, this section here will ride extremely high, 1/4 of an inch or more, or if we forgot one of the items, it'll ride way on the inside of the control. So now, lubricate the outside of that piston assembly with a little silicone, lay it back in, and as you notice, the top of this end plug assembly rides about 1/8 of an inch above the main valve body. Taking the plate assembly and the 3 small screws, starting those and noting that really there is no pattern as to going left, right, or around. What we're going to do is just crank that plate down, and again you can use a 5/16 nut driver, and when we go from side to side, we're going to draw the plate down, and when we draw the plate down, we're going to kind of compress those rubber seals that I took out before around that green piston assembly. That's what creates the seal. That's what the drive motor sees when it has to push that piston up and down to the various valve positions. Taking the power head, laying it on the front, noting that right here we have to line up this cutout in here with the main drive. You can pull up on the piston assembly so it fits right in. Take your screw here, hand start it because this is a self-tapping screw section. Snug it up, and now the 2 longest screws will hold the power head down, and that'll become our final assembly. So what we've basically gone through is the injector drain module assembly having 4 key areas. Again, the injector screens and jets, brine line flow control, brine valve, and drain line flow control. And the only reason we have to get internally to the control valve, again, one of 3 conditions: a leak coming out the drain, a leak coming out this green piston rod assembly, or if you tried to manually cycle it, the piston became frozen because foreign material has gotten between the piston and one of the spacer assemblies. We want to review the key areas of the control valve again, concentrating first on the injector drain module assembly, in which we have the injector assembly, the brine line flow control, the brine valve, and on the back side the drain line flow control. And then getting inside the control valve again, showing us the seals and spacers combination and the piston assembly as it's going up and down. The first area we're going to take a look at is the injector assembly. Again, the key areas of the injector is the injector screen, injector nozzle, and throat assembly. If the screen again becomes plugged up with sand, silt, sediment, iron, whatever, it's not going to allow the flow stream of water to go through the injector assembly and create the suction to draw the brine solution. Cleaning it again with either a brush or a muriatic acid will help keep this area clean and free flowing. The other area to take a look at again is the injector nozzle and throat assembly. And again we have those color coded. And reviewing that color code, it's red, white, blue, yellow, and green, representing the numbers 0, 1, 2, 3, and 4. Those colors of the nozzle and the throat assembly must always be the same color and match. You cannot mix yellow and green, red and white. The other section that you're going to see here in the control valve when that module is removed is this air disperser. That assembly is put into the control valve to help keep that throat of the injector assembly basically primed. Whenever you pass a vacuum on water, you actually draw some of the air out of it. And to keep this throat assembly always primed with water and not to become airlocked, that air disperser is put in there to put a little back pressure on the injector assembly to keep it drawing at all times. If when disassembling the control valve or working on it that air disperser is removed, falls out, what can happen is when you put it in the brine draw cycle and check for any suction on the poly tubing, there will be no draw, yet there will be no water coming out. It will become airlocked. Removing this assembly, checking to make sure that the air disperser is still installed would be the key thing. The brine line flow control assembly, and reverting back to the BTTB, checking the brine tank for the water level. If we had an extremely low water level in the brine tank where it barely refilled, that little rubber washer, the BLFC button down here, could become plugged with foreign material. Again, disassembling that assembly, cleaning it out of the foreign material, and when reassembling, taking a note that the bottom section here has some numbers on it and a beveled side where the hole goes through the rubber washer. That goes down into that retainer. There is no top or bottom to the retainer, so it doesn't make any difference which side you have up. But the rubber washer with the numbers down into there, and then slide the whole assembly up into the fitting. Now again, this assembly works like a check valve. When we're refilling into the brine tank, that rubber washer is pushed into the brass fitting, and we control the water going in. When we're in the brine draw cycle, that rubber washer button comes out into that retainer, and the brine can flow around the outside and through the center unrestricted. But again, if that becomes plugged up, a low water level will be noticed in the brine tank. The third area in the injector drain module assembly is the brine valve. And again, if the brine valve becomes stuck or foreign material gets underneath this half-moon rubber seat at the bottom, we're going to have a high water level in the brine tank. Higher than normal, possibly overflowing. Complaint could actually be salty water. And that's one of the reasons why when we showed that the last section of the BTTB, looking at that brine tank, the safety brine valve is a very advantageous item to use in the brine tanks. But showing again here that rubber O-ring at the bottom here has to be put into that drain module assembly first, then the whole brine valve reinserted after it's either been cleaned out or replaced. The last area in the injector drain module assembly is the drain line flow control. And when we were taking a look at cycling the unit through and noticing the different flow patterns running at the drain, from backwash, heavy flow, brining and slow rinse, a very light flow, rapid rinse and settling rinse, a heavy flow rate at the drain. And if that flow rate never changed, checking the poly tubing all the way back into the drain port here, if that was unrestricted, then removing the retainer, plastic retainer with either a special tool or a screwdriver in the slotted area, and then removing the drain line flow control button itself. And checking for any foreign material, pieces of wood, nuts, bolts, rocks, whatever, that could have gotten kicked up in the backwash cycle, and partially plugging up the drain line flow control button. Again, when reassembling, we want the flow pattern to come out of the control, the numbers and the beveled side go into the control valve first. And those numbers are three-digit numbers that we're concerned about. The three-digit numbers ending in 0. Like 120, 150, 200, 240 would be represented down here as 1.2, 1.5, 2.0 gallons per minute flow at the drain during backwash. These sizes of buttons also represent various size diameter tanks for backwashing when you fill the tank 2/3 with resin and 1/3 freeboard. The 1.2 gallon a minute will cover your 6 and 7 inch diameter tanks. The 1.5 will be 8-inch tanks. 2.0 9-inch tanks, 2.4 10-inch tanks, 3.0 12-inch, your 13-inch tanks, and 14-inch tanks with your 5.0 backwash discs. When tightening down this retainer back into the drain assembly, just snug it up. If you tighten it too tight, you could actually squash this rubber button and close off that center hole and restrict flow. Internally to the control valve, again, the only reason why you have to get inside the valve for either the seals and spacer assembly or the piston assembly is if, number one, we have a leak at the drain, number two, water or leak comes out the top of this end plug assembly, or number three, we get some foreign material hung up in this piston assembly to where we can't manually cycle that piston up and down. The piston assembly, when it's removed, what we're looking for, especially if we have a leak at the drain, is if we have any nicks or scratches in this Teflon coating on the outer edge of the piston. If there is, the cutouts in here are basically drain ports, and the water actually then goes out the drain. A leak at the drain is your main indication. We do have two types of pistons available. The one that's shown here gives us our normal cycles of operation of the preliminary rinse, backwash, brining, slow rinse, rapid rinse, settling rinse, and then back into service. We do have what we call a low water piston, which cuts the backwash and settling rinse times down, and actually water used per regeneration is cut in half. This top groove here is removed, and that cuts down on your basic high flow situations of preliminary and backwash cycles. Also, when reassembling this assembly back into the control valve body, take silicone as a lubricant, rub it around the outside, and then slip that assembly back into the seals and spacers. We keep stressing in these slides and in the service using silicone. Using any other type of lubricant that has a petroleum or a hydrocarbon base can greatly attack the rubber goods and also the plastic parts in their strength. So we stress again, use silicone, Dow Corning Compound 7 or Dow Corning Compound 111. There are a number of other lubricants and spray forms out in the market, but the propellant or the gas inside there in some instances has a hydrocarbon base and can also attack either the plastic or the rubber goods. The piston assembly, as it was shown in the previous picture, can be disassembled, and it comes up with 5 major components: the piston itself, a little connecting pin and retainer that attach through the piston rod for the actuation up and down for all the regeneration cycles. The end plug too also being the key area if the little seal ring in there becomes worn over a period of time, causing a leak coming out the end plug assembly. The other thing to take a check on is the piston rod. That again has a Teflon coating on the outside. Any nicks or scratches in that Teflon coating will cause a leak coming out that assembly.
Now we're going to take a few minutes to talk about the meter assembly and the bypass, and specifically what we would like to address is the 2 different model meter dome assemblies. We mentioned earlier that the standard meter assembly is good for applications up to 2,150 gallons. Well, if we had a situation where, let's say we had a cubic foot unit and 24,000 grains of capacity recovered, but we only had 4 grain water, we would have 6,000 gallons of capacity, but we would not have room on the meter program wheel to program anything in excess of 2,150 gallons. So what we simply do is we add what we call extended range referring to this additional small dome on the top of the meter dome, which gives us an additional 5-to-1 gear reduction, which means in terms of our programmable gallon readings, we can now put up to 10,500 gallons on the meter program wheel. So in our example where we've got 6,000 gallons of capacity, we would deduct something for the reserve capacity and program opposite the white dot, let's say 5,500 gallons if that's the appropriate usable number that we had. As far as servicing the meter, there's always going to become a time when we have to be able to determine if the meter is doing its job. And it's a very simple procedure. It's 3 steps. The first thing we want to do is we want to take what we call a meter checker disc, which is simply a round plastic dial with a decal with gallons scaled around the perimeter of the decal. And we're going to remove the cable which would be in our meter assembly and insert this disc right over the top, rotating it until it can be pressed firmly in place down over the top of the meter dome. The second thing we do is we're going to take the meter cable, which will be out the back of the control, and we're going to insert a little finger indicator, which has a very fine hairline molded down the center of it, and we're going to put that right over the end of the key on the end of the cable. And now we're going to plug this end of the cable in. This will be in the back of the timer. And what we want to do now is just open up a service tap and let a few gallons of water pass through. And as the water is used, if that impeller is registering flow properly inside, what we will find is that the little finger indicator on the top will begin to pass over those gallons, which are scaled on the scale of the label on the top of the meter checkered. Okay? The second step, if that checks out, we want to make sure that the clutch assembly in the timer is working properly. And let me demonstrate how that's done. Notice as I turn the cable, the program wheel turns counterclockwise. Eventually the stop, when it gets to the 270-degree position of the manual gear, we pick up a clicking noise, which is simply the clutch mechanism slipping, and each click represents approximately 50 gallons of water. Now, some of the obvious questions I've heard asked at previous service schools are, will the clutch ever wear out? Well, keep in mind that that clutch slipping, each click being 50 gallons per click approximately, and the only time it's going to slip will be when it's on the reserve capacity. Okay, so the likelihood of it wearing out is virtually nil because you're not actually going to have it working in that mode that often. But when we check out the meter, we want to make sure that the only time we hear that clutch clicking is not when the pointer is over here, but only when it's up against the stop. Okay, that tells us that the clutch is working good. If we can take the cable and spin it and not get a clicking noise, that tells us the clutch has got the right spring tension on it. The only time it makes any noise is when it's up against the stop. All right, the third thing we want to do is we want to go to the label, that is the hardness label, the inside diameter label here, and there should be a little code printed right on the label. This one happens to be 24K cap, which is the abbreviation for 24,000 grains of capacity. And that tells us, if we have a cubic foot unit salted at 8 pounds, that the hardness label on the front is compatible with the salt setting that we have on the back side, and that the capacity that the unit is truly delivering after regeneration is the 24,000 grains. Now, if somebody changed the salt setting back here, either reduced it or increased it, the 24,000 grain label on the front would not be the right label. And therefore, we would either be using too much salt or we would be running out of conditioned water before the meter was ready to regenerate, which has been referred to previously as a capacity problem. So to avoid capacity problems, don't cut back a salt setting on a demand system. Okay, the next thing I'd like to show you is this little information booklet on the meter. In the back, the very back, there's a list of 15 of the most often asked questions by service people who work with the meter for the first time. The answers to those questions are also back there. And for someone who is using the meter for the very first time, if they would review those 15 questions and answers, they could find themselves 95% confident in working with the meter, because these are the typical questions that somebody who has used the meter for the first time that they would normally ask. And when the product was new back in 1982, we kept track of the questions that were raised by everybody at that time, because it was new to everybody. And we found that this was one of the best ways to train people coming along, starting up using it, by reviewing with them what other people's experiences were as far as the questions that they asked. Another nice handy thing in here is the explanation of the capacity labels that we just talked about. It tells us why we have to have compatibility between a K label on the front program wheel dial and the salt setting on the back. So for those of you who may want a little more in-depth detail as to how the K labels and the salt settings must be matched up, that information is in the centerfold of this book. And there's also some information for the salespeople in the organization up front. Why demand regeneration systems are the buzzword of the industry, so to speak, today. They save salt, water, sewer use taxes, use less salt, therefore you carry less home from the grocery store, and they may find that interesting in the sales department. The next thing I'd like to cover is when the meter was being developed back in the early 1982 period, we had several problems, and we did have a recall on the meter assembly. Every meter up to, and I guess it was the 9,000 serial number, in the low 9,000 area, was recalled at one time. And there was a variety of different problems that plagued the meter assembly at that time. There is a tag which we have on the valves that we used earlier, a metal tag that's mounted under one of the 4 dome mount screws, which tells us the serial number of the meter. Now there's nothing to worry about today because, as I mentioned earlier, there are over 200,000 meters out at this point in time. But I do want to acknowledge that there were problems in the early years with the meter, and there was a problem affecting meters back about a year and a half ago where we were using too much torque to tighten up these 4 screws on the meter dome assembly. And what would happen after the meter would be in the field for a short period of time, hairline cracks would develop on one of the 4 corners, and eventually we would develop a leakage at that point. That problem was put to bed at serial number 75,600, which is approximately 140,000 meters ago in terms of serial numbers, and we're talking about a year and a half to a year and 3/4. So those 2 major problems did exist. They're behind us, and we just want to, acknowledge that we did have that problem with the screws being tightened down too far. Today, we suggest if you have any problem with a meter, any problem at all, let's say heat transfer on installation where maybe the plastic melts, or maybe some solder or stones get inside, or some resin gets into the meter dome, which can happen if the unit is plumbed in backwards once in a while. If there's any damage at all to these gears up in the top, exchange the whole module. That's the easiest way to do it. Now, some people would prefer to change the dome assembly. There is a procedure for properly changing the dome assembly, and that entails removing the 4 screws, taking the dome off, and then when you put the new dome on, have the dome assembly in the palm of your hand upside down. You can hear that noise in there. That's the slack in the gear train. We have to get that slack in the gear train such that when the dome is positioned upside down, then we take the meter base and put it on top. Using that procedure, we can then be assured that the output shaft in the bottom of the gear assembly in the dome matches up with the small gear teeth on the top of the impeller, and we don't have any galling of those gear teeth. But as I said earlier, it's best in the infrequent situations where you should have a need for a meter, change the whole module. That's the easiest way to go.
Excuse me, Bill, before you go any further, can I just have the meter and the meter checker?
Sure.
And the meter. One thing, when you are checking out a meter assembly, determining whether or not it's, let's say, registering gallonage, and when Bill said put it on there, you'll notice that we have a number of scales around the outside perimeter. This one meter checker can handle a wide variety of different meters that we manufacture: 3/4, 1 inch, 1.5 inch, and 2 inch meters. The type of meter that's used on a 5600 is considered a 3/4 inch meter. So when you put the dial in the front and you insert the cable in, we're looking for the 3/4 inch meter, which is this scale right here. We just turn that clear pointer, that finger pointer, to the 0 position, then run water at the stationary tubs or some conditioned or soft water outlet port, And each one of the hash marks represents 1 gallon. So 10 gallons run off, 10 hash marks. If the cable's inserted it here and into the timer assembly, then the malfunction or the problem has to occur something outside of the meter assembly.
Okay, thanks, Mike. Many times when we think we're going to need to use the meter checker, what we really have is a capacity problem, as Mike related to earlier. If there's a large amount of water that's going through the service lines of the home that isn't being registered by the meter, a leaky toilet, maybe that in combination with an RO unit, any number of things, we may feel that the meter is not registering flow because there is a high proportion of the total water going through at less than 1/4 gallon per minute. The meter checker really, if the impeller is turning and evidenced by the movement of the little finger indicator on the top, what we should really do is take that hardness reading from when we tested the water in step 2 of BTTB and go right back to the front of our timer and make sure that we've got the appropriate program on the timer. Do we have the right number of people in the family? Do we have the proper hardness? And if there's iron in the water, did we compensate for the iron? Did we allow a factor of 4 for every part per million of iron and add it to the hardness? If there's an RO unit under the sink, did we put in an additional person? Because a typical family, you would use an average of maybe 75 gallons approximately of water per day per person. So if you had a family of 4 and you found that the unit was running out of conditioned water the day before regeneration consistently, that would tell me right away that it's a capacity problem, because the unit regenerates automatically. The only problem is it regenerates 1 day too late. So what we have to do is go right back to the timer and we have to find out why we're always 1 day too late. And we'll probably find there's a reason for water flowing on a somewhat continuous basis through the service lines of that home that cannot be registered by the meter. And so we adjust for that. Okay? And we can either add a fictitious person to that family, which would mean we're putting an additional 75 gallons of reserve in the program, or I alluded to the fact that maybe you want to increase the salt setting before so that we get more capacity recovered on regeneration. So if you have the thought that the meter may not be working, 8 times out of 10, 9 times out of 10, it might be that we don't have the right program on the front of the timer. So just keep that in mind. Okay, then the next thing I want to just spend a minute on is the bypass assembly. It's an optional extra that is available. It's a very handy device because when we install the unit, we only have 2 connections to make on the house side, since we're already mounted up to the back of the valve. It's kind of a unique bypass valve because there's no moving part in stream. The part that moves when we throw the handle from service to bypass is a molded plug, which is actually inside of that rubber boot. So when we turn the handle, we're flexing the boot. We're not moving anything in stream, which means if the bypass valve is in service position for 3 years and the serviceman comes out and he has to put it on bypass in order to work on the unit, the handle is not going to be in a permanent stuck position because there's a moving part that can't move because of the fact that the unit was in that position for a long period of time. We'll find that it'll move relatively easy from bypass to service or vice versa, irregardless of the length of time that it sat in that position. Another point I'd like to make is if you were to hold this up to the light and you had the handle in the service position, you would discover that there's just a sliver of daylight that you can see coming through there. And that shouldn't lead you to believe that there is excessive pressure drop across the bypass, because if I take my pen and put it in and press in on the rubber boot, you'll see that it moves, which is exactly what happens when there's water pressure acting on the rubber boot inside. So when it's under water pressure, there's full flow through here. Yes, there is a pressure drop, but it's very slight. Nothing like what you might believe if you just held it up to daylight and assumed excessive pressure drop because of just a sliver of daylight. In installing the bypass valve, it's mounted to the valve on one side. We have to be careful that we don't transfer heat to that rubber boot inside and the plastic plug which flexes the boot. So we always recommend that you solder at least 4 inches away on the inlet and outlet side of the bypass. And if you can, use a solder that's going to have a melting point not like silver solder. And I understand that in some areas there are codes where you can't use 50-50 solder or other grades of soft solder. But if you must use the 95.5 or the silver solder, which has extremely high melting temperatures, make sure we put a wet rag over the top of the bypass and keep the heat at least 4 inches away from the end of the bypass. You may want to go in with your pipe thread to sweat adapter. Maybe you sweat an extension on that so that we can work even further than 4 inches away from the bypass. And that'll help, you know, when you get the unit all installed and you get the toolkit closed up and you throw the bypass handle into the service position, there's not going to be a chance that you have water leaking out because of the rubber boot inside being burnt or the plastic plug being deformed. So if you take that little extra care in installing, the bypass valve should last well beyond the life of the unit. Mike, do you have anything to add?
One other thing. For those of you who use the bypass valve or the 5600 for the first time, typically when you're installing it, the unit will be in a bypass position. First-time installers many times will elbow right out of the inlet and outlet, and when they go to turn the bypass on, they hit their fitting right here. So that little precautionary, adding that 4 or 5 inches, 6 inches to the fitting that goes in the inlet and outlet will allow a free flow then of the bypass lever. That's all I got.
Okay. One other concern that some people have with the bypass or the yoke, which is mounted on the back of the valve, they notice that there's quite a bit of play when the valve or the yoke is in position on the back of the control. The valve was designed that way so that if we don't have perfect center line dimensions when we're cutting our copper tubing and coming in matching up to the valve, we're not going to have a continuous cross force on the back of the plastic valve because our fittings are designed with an O-ring on each side to allow a little forgiveness for the plumbing to be off a little bit. So don't be concerned about the yoke or the bypass being loose on the back of the valve, so long as the clip which bridges the flange of the bypass and the flange on the back of the control is engaged and the screw is turned in to hold the clip in place. A few final comments on the meter assembly. On a tag mounted beneath one of the 4 meter dome screws, we have a metal serial number tag that tells us the date that the meter was assembled and the customer for whom it was made. It also gives us insight as to how many controls were made in that production run. If you should have any questions on the meter assembly, it's sometimes helpful to refer to that number if you're contacting the factory, and that will give us the point in time when that meter was manufactured, and it'll help us in answering some of the questions that might come up. It is also the date that tells us the beginning of the warranty period for the meter, 36 months from the date forward that serial number indicates. Should you ever feel a need to replace the meter assembly, we would suggest that whole module be replaced, not just the dome. Should you ever want to replace that dome, remember that when you put the assembly back together, we must tip the meter upside down and remount the new dome assembly. And also you must remember that the amount of torque that you put on the 4 corner screws should be nothing more than just finger tight, because we have an O-ring seal between the dome and the base of the meter, and 5-inch ounces of torque is all it takes, and that basically by definition is finger tight. No wrenches required. It wouldn't hurt if it was turned a quarter turn beyond that, but it really isn't necessary. Again, our meter assembly standard range and extended range. The extended range meter has the additional small dome on the top with the additional 5-to-1 gear reduction. We had mentioned earlier that there was a time when we did run into some problems in the field with the meter domes cracking because the screws holding the dome on were over torqued at the factory. When that problem was discovered, that was back at 75,600 in referencing the serial number, and at the time that we found that problem, we did add a fiberglass fill to the dome of the meter cap assembly adding an additional element of strength that we did not have before. And that, coupled with using the proper amount of torque on those screws for tightening them up, should keep us away from any future cracking. The three basic components to the meter body assembly is the standard gear train comprising of 8 small step-down gears, which are sealed in the dome assembly, the impeller, and then the base of the meter body itself. We're going to wrap up today's session with a list of service and installation tips, and let's start with a couple of items that we've already mentioned that we can't overemphasize, and that is, 1, always use only silicone-based lubricant. That covers the teal O-ring, and that's on any internal parts, and try to use liquid or paste. Don't use silicone and aerosol cans, because many times the propellant is petroleum-based, and that has the same adverse effect on the plastic and rubber parts as a petroleum-based lubricant would have. The second thing we'd like to remind you of is, let's not use pipe dopes on the drain line connection. There's about 38 different pipe dopes on the market, half of which adversely affect plastic, the other half do not. And what we want you to do is use 2 wraps of Teflon tape and make that connection hand tight. You're venting to atmosphere, there's not going to be any great pressure at that connection that you're making, and so there's no pipe dope necessary, and there's really no wrench necessary if we just snug up that fitting hand tight. The next thing we'd like to suggest is, when you solder, as we mentioned earlier, solder at least 4 inches away from the bypass valve or the yoke. And the reason for that, we don't want to transfer heat to any of the plastic or rubber components, and if you can, we want to avoid using silver solder. In some areas you can't. In those cases, we want to make sure that you put a wet rag over the bypass to protect the plastic plug and the rubber boot inside. The next thing we'd like to cover is the date coding of the motors that are on all of the controls. We use a 4-digit number to indicate a date code. And let's, for example's sake, take the number 2144. The first digit, the 2, represents the month of the year when that motor was made by our supplier. The middle 2 digits represent the day of that month, and the last digit represents the last digit in the year. Since we have a 36-month warranty on our motors, it's important that you be able to interpret those numbers. And when you do send a motor back to the factory, take some care in wrapping it up, and so that it doesn't arrive at our place with a dented cover, because we'll assume that the motor was dropped and that was the reason that it failed. So we do expect the motors to arrive at our shop, if they are in warranty and you expect a replacement for them, at least in a state where they're not physically damaged. The next thing we'd like to remind you is, always use an air gap on the end of the drain line. It's code in many areas of the country. It is important for 2 reasons: the health aspects, and secondly, many times the injector assembly will not work if the end of the drain line is underwater anyhow. So always use an air gap. The next tip is kind of related to the use of an air gap, and it's don't ever put a drain line directly into a sewer pipe, because that definitely is against the health codes, and you could have very serious problems if you do that practice. When you're working in a home and you're tempted to get all the hard water out of the water heater, get rid of the temptation. Don't open the drain valve on the bottom. And the reason for that is, there's going to be scale in the bottom of the water heater, and some of that scale, precipitated, may end up in the area of the valve right on the seat, and if you try to close off the valve after you drain the water out of the water heater, there could be some scale there, and you'll permanently damage the hand valve, and you could become the proud owner of a water heater, because the thing cannot be shut off after you've got a permanent dent in the seat of the valve. So leave the hand valve closed, and just let the hard water that may be in the water heater get out of the water heater through normal use of hot water. As Mike said earlier, it'll usually take about 3 times the rated capacity of the water heater as far as total flow through in order to rid the water heater of the hard water. The next thing is never mix injector throats and nozzle colors. We covered that before. They must be compatible. White goes with white, red with white, and so on. The next point is when you go on a call and the unit is leaking to drain in the service position, that's a key to go into the main valve and look for either a damaged seal or a damaged piston or a broken spacer. That's the only time that you really want to tear into the valve, when you have water leaking to drain, either dripping or a constant stream of water, when the cycle indicator knob on the front says you're in a service position. Don't forget to compensate for iron. We suggested before you use a factor of 4. Every part per million of iron multiply times 4 and add it to the hardness. And that's going to assure you, especially on your meter installations, that the meter is going to be calling for a regeneration at the appropriate time, not supplying hard water for an extra day and then you getting a phone call and having to go out and reset the timer and compensate for that iron. When we manually regenerate the control, we said you would turn the manual knob until you hear 2 clicks. It will be in the regen position as evidenced by the call out on the front. You should see water running to drain almost immediately after you turn the valve to the regen position. Slow at first, it will gradually build up to the rated drain line flow control flow rate. But give it time. Don't turn it to the regen position and say, well, it's not flowing at 1.5 gallons a minute or 2.5 gallons per minute, whatever the flow control size is on the drain line, so there must be something wrong. Remember, the piston lobe has to position itself in the appropriate spot opposite the adjacent ports in the spacer before we're going to get full flow. Another thing to remember is when you're out checking out the motors, a warm motor does not indicate the motor is good. If the coil is shorted, the motor will be hot, but the rotor will not be turning. The proper way to check the motor out is remove the cover, look in the back, and look through the sight glass on the back of the motor. If you can see the rotor spinning, then you know the motor is good. When we clean the injector nozzle and when we clean the brine line flow control button, always use a toothpick, a round wooden toothpick with a slight taper on it, because we don't want to put a permanent mark on the inside diameter of that brine line flow control button. We don't want to scratch it or rip it. Likewise, we don't want to put a permanent mark on the inside diameter of the injector nozzle, which is plastic. Once in a while we maybe get tempted to use maybe a paper clip or something like that, but a paper clip is a piece of wire that's got a sharp end on it because it's just sheared off, and you could scratch or damage permanently the flow control button. Remember, when we're using a brine system with a grid, that it takes 4 hours to make saturated brine. If we're not using a grid and we have the total amount of water that refills the brine tank in contact with salt, and if the salt level is above the refill liquid level, it only takes about 10 minutes. But when we're using a grid and the salt is supported up above the refill water, and we only have about 1 inch of water in contact with the salt, it'll take a full 4 hours at 70 degrees Fahrenheit. So we want to keep that in mind, especially on maybe some of the light commercial applications where we're regenerating a twin system. Another point, this is for the installer, and that would be to make sure the unit is in the service position when you pressurize a tank. Sometimes the installers feel that if the valve is not in the backwash position, that we're going to trap a head of air permanently in the tank. That head of air in there isn't going to hurt anything because we're going to purge it out after the tank completely fills with water. The problem you could run into if you have it in backwash is you may lift some of the resin fines up into the piston seal spacer area in the valve, and then we're going to have the leak to drain problem right upon completion of the installation. And so we want to keep the media in the tank, and the best way to do that is have the valve in a service position so that the tank fills with water, with the water coming into the valve and flowing down through the system instead of coming in the bottom distributor of the tank and rising up through the valve. The next thing we want to mention is do not lay a unit down when you're transporting it from your shop over to the job site. Again, you could get some of the resin up into the valve seal piston spacer area, and that could cause a leak to drain. Another thing, kind of obvious, we don't want to see them installed backwards. Our inlet and outlet orientation on the back of our control is the opposite of another popular valve in the marketplace. We do have raised arrows embossed right in the brass casting on the bypass valve and on the yokes to remind you that as you look at the valve from the back, the right side is the outlet and the left side is the inlet. If you should install a unit backwards, and if it should be a metered unit, what will happen is that the meter program wheel will turn the exact opposite direction, and you will never get an automatic regeneration because the pointer on the meter program wheel will be approaching its index point from the opposite direction. So install them with the inlet on the left side as you look at the valve from the back, the outlets on the right side. And if we should forget that, just take a look at the embossing on the back of the yoke of the valve or on the bypass, and we'll see some arrows embossed in there to remind us. Another tip comes in the area of the drain line configurations and the size of drain lines. Let's always remember to use a minimum 1/2 inch diameter. And the reason we like to see you do that is sometimes the drain lines have to be long, sometimes we get by with short ones, but if we can kind of standardize on a 1/2 inch diameter drain line, the likelihood of an injector being getting too much back pressure from the friction loss of an extremely long, small diameter drain line is not going to be there. And also, if we're installing a unit in a basement, as many of the units are installed in the northern parts of the country, many people have their basements fixed up with recreation rooms. The drain line may go up to the ceiling and then run across the ceiling to the opposite end where it drains into a sump pump. Well, in those cases, we get the additional back pressure from the vertical rise from the valve up to the ceiling. So if we just use a 1/2 inch diameter drain line, there won't be any problem at the injector. Another thing that we should mention, and this applies to outdoor installations, particularly in the extreme south where it's common for outdoor installations. If you suspect freezing, you should take precautions and somewhere in the service line open up one of the service taps just a little bit so that water will drip through or run at a very slow rate through the evening, through the night. Traditionally, on average, a couple times a year, even as far south as Tucson, Arizona, and halfway down the state of Florida, we'll have freezing conditions, and we should have the homeowners alerted to the fact that if there is going to be freezing weather and the unit is outside, the mechanical force of ice forming inside the valve is so strong that nobody can guarantee that the valve can withstand that force. So the best thing to do is warn them to have one of the service taps open so that we have water moving continuously through the valve so it doesn't get an opportunity to freeze. So we want to remember that on the outdoor installations. Another thing we want to remember is that important formula that Mike told us about before, the BTTB. And if we use that systematic approach, we should be spending the least amount of time at a problem job or on troubleshooting a system, and that's what we want to do. We want to work smart, not hard.